Hello, this is Team 2 presenting our design pattern on the flyweight design. Our team consists of Alexandra, Josh, Joshua, Spencer, Sam, and Will.
Let's talk about the flyweight pattern. Flyweight takes state data and scatters it into multiple objects so we can save on memory. It takes data that doesn't change, which is called intrinsic data within the pattern, and places it within a class that is then referenced by a class that holds on to data that does change. Things like extrinsic data. Extrinsic would be something like a location, could change. Intrinsic would be more like a color or specific shading, that sort of thing.
All right, so this is what it looks like before you apply the pattern. You have the tree with its intrinsic data and the other data. We have the coordinates, name, color, and texture, but we can shorten that down and remove all that unnecessary data in each object. Here's an example. So right here, we moved all of that core data into the tree type. It has the name, color, texture, and we have all the other variables that change depending on the tree in the tree itself. So instead of like rendering 300 trees with all that information, we're only having like 3 or 4 tree type objects with like 300 or more trees with individual data.
Okay, now places where you've seen it before, like it was mentioned earlier, there's that rendering example. Many 2D and 3D engines like Unity and Unreal Engine utilize Flyweight pattern to render tons of objects like 10,000 trees to have a shared texture and individual position. Other popular ways to utilize it is fonts and character systems on Windows and Mac OS, map and navigation systems on Google Maps, and then browsers also commonly utilize Flyweight as well as financial software.
So this brings up a lot of pros and cons to the software design. The first con would obviously be that you have to separate and make a distinction between intrinsic and extrinsic data. Um, this isn't always intuitive. It kind of depends on the project, the team, the developer, those kind of things, and that can consequently make things harder to maintain. Code can become less straightforward because, again, you have to make clear lines and distinctions, making debugging a little bit trickier. And it's honestly not always the most helpful design pattern. It won't always make everything more efficient. Um, this adds an extra indirection, so you often need a factory or a lookup system, and this adds overhead to the entire system. However, that said, with the pros, there's a huge memory saving. This is very evident with the example that we will see on the next slide. But when you have many similar objects, maybe whether that's, leaves or player types in a video game, things like this, duplicating large data is where it's most beneficial. So we'll see that it scales well for game engines and text editors, rendering systems, etc.
Thank you, Will. So we can see even in this simplified example that we see huge memory savings, roughly about 800 times, even when we're just rendering grass. You can pause and look at these numbers if you like, but for the sake of brevity, we're going to move on to the realistic example that talks about a million individual trees. We've been talking about, rendering grass and trees this whole time in either a simulation or a video game because it's absolutely necessary in this case. Like, as convincing as the cons may be, you just have to put up with them because we do not have 1.2 terabytes of memory on the average computer where this thing needs to run. It's just not possible. We need to use Flyweight to reduce that by 18,000 times down to just 65 megabytes to render all those trees.
So in summary, our key takeaways are we use Flyweight to reduce memory usage when working with many similar objects. Also, we separate shared intrinsic data from unique extrinsic data, and we reuse common data instead of duplicating it in every object. So this allows us to handle a large number of objects efficiently, and we can use this typically it is typically applied in cases like games, text editors, or graphics, also financial software, where many objects repeat the same information. Overall, we use Flyweight to make our programs more efficient and scalable. Thank you.